Hello everyone, welcome to Priyan classes. I'm Prabhat Kumar once again with you. Today I'm taking this very first topic for 11th standard, that is related to sets. Okay, now what set is, before I start, it is a very interesting topic and very interesting chapter, and it will be helpful in understanding your future concepts or what future chapters will be telling you. Okay, everything will be depending on sets. So before I start, I would like to tell you what is a set. It is a collection. For example, a collection of objects. If you go on collecting names of students of a class, then it becomes, you get a list. This list is called a set. Okay, similarly, if you take the names of all the students of an university, if you take names of all the students of a committee or all the members of a committee, so all these things are called set. So set is what? It is a collection of objects. But normal collection or simply collecting objects will not say it to be a set. I have kept a gap there. Why? Because you see, if I say just set of students or collection of students, what kind of students? Students may be of standard 11th, may be of standard 1, may be of standard 2, may be of school A, may be of school B, may be of school C, whatever it is. So there are so many kinds of students. Until and unless there is a complete definition or a definite definition of the objects which are to be collected, it will not be called a set. Remember this thing. So set is what? It is a collection of well-defined objects. Remember, this is the basic word. As you must have studied in English also in your literature classes, whether it is in English, whether it is in Hindi. What is the definition of a sentence? Sentence is a collection of words, but all collection of words, if I say is, are, am, this is also a collection of words, but is it giving you a meaning? No. So until and unless it is giving a meaning, it will not be called a sentence. Okay, so sentence is what? It is collection of a meaningful, or I should say it is a meaningful collection of words is a sentence, not all collection. Similarly, if the objects are well defined, then only it will be called a well-defined collection or a set. Okay, so now there are some different, for example, if I say set A, it is a collection of students of class 11th of school A. Okay, now this is what? This is defining the collection. This is defining the collection that student is studying in school A. Again, in school A there are several students studying in different classes. Then student of class 11th. So this is a proper definition of the set. If this definition is not there, it will not be called a set. Okay, so now there are some standard sets also which we have been using in different topics and different subjects. What this is what? There are some standard representations. For example, whenever I said n, this is what? This is set or collection of all natural numbers. Okay, this is collection of all natural numbers. Okay, similarly, when I say Z, what it is? It is called, or I say W. And you know what natural numbers are? The counting numbers which are starting from 1. So maybe infinity, number of sets may be infinity, number of elements. So each member of that object or each object of that set is called the member of the set or the element of the set. Okay, so here number of elements may be more. It doesn't mean, but it is similarly W is represented as set of all whole numbers. Now what is the difference between these two? The difference is only one member, that is 0. The counting number starting from 1 is natural number, counting number starting from 0 is whole number. Rest all is same. Similarly, if I say integers, somewhere it is written as Z, or in some books it has been presented as I also. This is set of all integers. Okay, now these integers may be positive, may be negative. If you want to make it more specific, more defined, then like set of all positive integers or negative integers, then we just put a mark there to make it like Z plus or I plus for collection of positive integers, and similarly Z minus or I minus, these are for negative integers. That is just marking, small demarcation, but the Z is represented, Z or I are represented as set of all integers. Then there is Q, that is set of all rational numbers. And you know what is the definition of rational numbers? A number which can be represented as P by Q, where Q will not be equal to 0. This is the definition of, and if you collect all such numbers, that will be the collection of all rational numbers and it will be presented as Q. Then comes R, that is called the real numbers or the set of real numbers. Okay, so these are some of the sets which are represented by some specific notations, okay, that has been given to you. Now there is one thing, as I told you, that each object, as I mentioned, each defined object which is member of the set or which is called an element of the set, can we count it? Obviously in these cases it is not countable, number is infinity. But if there are some sets, as I have given you the example, that collection of all the students of a class in a school, obviously the number of students will be limited, so it can be counted. So that is represented by the number of elements in a set A. It is represented as small n and then A under bracket. Okay, this will be, I will use this notation further in my video. Okay, so this is represented as NA. Now how do we represent the set? Representation of sets is what? This is what is a set. This is all, as I have told you, that it is a collection of well-defined objects. But what if you are given a definition? How will you make a set, or how will you arrange the members, or how will you arrange the elements of the set? That is called representation of a set. There are two methods. Okay, there are two methods. First method is called the roster form. Or it is also called the tabular form. Tabular form or tabular method. Okay, what it is? In this case, the specific numbers are represented. For example, if I say that A is a set of all odd numbers less than 10, okay, then I will represent A as the sets, the elements of sets are represented as under this middle bracket or the braces. Okay, they will be represented you have to use this bracket only always. And now all odd numbers, or I should specify it, all odd natural numbers. Okay, so what these are? These will be 1, 3, 5, 7, 9. So when I am writing the name of the elements, or if I am writing the element specifically, this is called the tabular form or the set or the roster form. Okay, so this is your representation in this form. Then there is another form that is given as set builder form. In this form, we do not write the specific elements, we just write down the definition, and there is a specific format for writing out the definition. This is just a statement form, but this is not a set. When I said what is set A, then set A will be, it will be written as X such that X is an odd natural number less than 10. Again, you have to use this only. Some books, instead of colons, they are putting a bar also. Okay, so that is also correct, that is not any problem. So this is how we write it as set builder form, where the definition of the set is given. Okay, now some specific kinds of set, what it is. For example, you see what in this example what I have given to you, you see there the number of elements or the list of the elements is limited. Okay, list of elements or list of members is limited. In such a case, it is called a finite set. Okay, so I will rub this out. So from my previous, what my A was 1, 3, 5, 7, 9. You see here, if I say what is NA, number of elements in the set A, this is what 1, 2, 3, 4, 5. So this is equal to 5. But if you are getting this as a definite value, the number of elements is having a definite value, then this type of set is called a finite set. Okay, it has got a definite value. Okay, so that is why it will be called a finite set. But if I say A as, or say take another set B, is a set of all odd natural numbers. See what I have deleted. The condition that it should be less than 10 I have deleted. Now what will be set B? 1, 3, 5, 7, 9, 11 and so on. It will keep on. So can you count the number? No. Number cannot be counted in this. So what this is called? If I find out, if I say what is NB, anyone will easily say it will be an infinity. Okay? It will be an infinity. So that is why this set is called an infinite set, where number of elements is not limited. Number of elements is infinite. Okay? But now there is another condition. If I say set of all odd numbers or odd natural numbers divisible by 2, is there any? If your set is defined as, suppose that if I say A is a set of all odd natural numbers divisible by 2. Okay, what will be? Will there be? Can you get any such number? Obviously the answer is no. So that means this A will be, there will be no element in this, and this type of element is called an empty set. Okay, it is called an empty set, or it will be represented as a Greek letter phi. Okay, so what will be NA equal to in this case? Because there is no element there, so NA will be equal to 0. So I can say if NA is equal to 0, then it is a phi, or it is a null set. It is also called a null set. Null set or empty set, or in some books it is also written as a void set. So it has got 3 names: empty set, null set or void set. It is a set which is not having any defined member in the set. Okay, or number of elements in that set is equal to 0. Okay, so that is called the empty set, or so this is what. Now there are another thing, what will be an equal set? When I talk of equality, that means I will be talking about 2 sets. Okay, I will be talking about 2 sets. So if there is one set A and there is one set B, okay, and if there is an element A which belongs to A, this is epsilon represents that it belongs to A. That means this small a is a member of A, or it is an element of A. If this implies that A is also a member of B. Okay? If it is in A, and another thing, first is if A belongs to A, it means that it is in B, and if A belongs to B, then it means that A is also belonging to A, means vice versa. If there is one member, if you take one member of one of the sets, it means that it is a member of another set. Okay, that is, if A is written as 1, 2, 3, 4, 5, these are the elements. Now B, this is written as 2, 4, 1, 5, 3. Just it is the shuffling of, it is the arrangement of. One thing I left to say you, that when I represent this, when we are saying in a tabular form or a roster form, remember the elements will not be repeated. Even if the element comes 2 times, it will be written once only. I will just give you this also. Like, suppose that if there is one X, it is set of letters of the word school. So this X will be written as what? S, C, H, O. Now this O is repeated, so I will not write it again, it will be just this. Okay, so this is what is about the tabular form or the roster form. So now in this case, you see, any member of this, any member of set A is a member of set B, and similarly any element of set B is an element of set A. If this is happening, then I can say set A is equal to set. Okay, and similarly if I say NA, it will be equal to NB, because number of sets of set NA will be equal to number of sets in set B. Now what is a subset? Now we are coming to the main part of this theory, that is subset. Okay, what is a subset and how do we represent? Suppose that there are 2 sets A and B. Okay, earlier I have taken 2 conditions. An element in set A means that it is an element of set B. An element of set B means that it is an element of set A. But in this case, I will just drop out one of the conditions. I will just say only one thing, that if there is an element A which is belonging to A, this implies that A is belonging to B. Vice versa, I am not taking. Okay, I am not taking vice versa. That means, suppose that A is 1, 2, 3 and B is 1, 2, 3, 4, 5. Now you see, if it is an element of A, it is an element of B. But if it is an element of B, it is not necessary that it will be an element of A. Okay, it is an element of B. These 2 are the elements of B, but these are not as elements of A. So in such cases, that if A is all members of A or all the elements of A are the elements of B, then I will say that A is a subset of B. Okay, and it will be represented as A is a subset of B. This is its representation. And similarly the other way also, I can also say that in this case B is a superset of A, or I will be writing B is, it is, if you see, it is just a transformation of, like, A is less than B and B is greater than A. Okay, if A is less than B, the value of A is less than B, or if it is coming on the number line, if it is coming on the left hand side of B, then it is called A is less than B. Similarly, less than B and greater than B is greater than A. So this is what do you mean by subset and superset. Okay, now there are intervals. Okay, now interval is what? If I say, okay, before I moving to the intervals, I will just give one two more things, like what is a universal set and what is a power set. Suppose that you are given some sets A, B, C, D, okay, and there is one set X such that A is subset of X, B is also a subset of X, C is also a subset of X, okay, and D is also a subset of X. So the set which, if all the given sets are the subsets of one given set, so this becomes what? Father of all the sets, I should say. So this X is called the universal set, and it is represented by U. Okay, so what it is? Suppose that I will just give you a practical example. If I say, as I have told you, that N is a set of natural numbers. Okay, what was W? Set of whole numbers. Okay, and what was I? Set of integers. And in this case, U will be set of all real numbers. Now you see, all these are, if it is a natural number, it means a real number. If it is a whole number, it is a real number. If it is an integer, it is a real number. So all these are the subsets of U. So that is why U, or what should be written as R. So this R is what? R is the universal set, okay, which is containing all those subsets, all other sets. If this set is containing all other sets, this is called the universal set. Okay, now what will be the subset? Now if I say, if you are given a set, like set A is given, you are given 1, 2 and 3. Okay, if I say write down all the subsets, first subset write A, first thing 0. 0 can be subtracted from all numbers, you know. Okay, so 0 is the, or if you say the factors, then 1 is the factor of all numbers. Okay, so first of all, this will be A1, the first subset will be 5. Okay, then the second subset A2, taking all single elements. A3 will be 2, A4 will be 3. Can there be more? Maybe. And A8 will be equal to 1, 2, 3. That is the set itself. Remember, as you know, that each number is divisible by itself, or each number is a factor of itself. Each number is a multiple of itself. So similarly, we in this case also we say that each set is a subset of itself. Okay, each set is a subset of itself, and each set is a superset of itself. That is also true. Okay, so these are, when I take collection of all sets. Suppose that I say X, it is set of all subsets of A. What it will be? A1, A2, A3, A4 up to A8 I have got. This is like that. Or I can also write it as 5, 1, okay. This set is called the power set. This set is called the power set. Okay. So this is all about how do we find out sets, how do we find out how to represent a set, okay, how do we, what kinds of set can it be. And now the remaining part of this is how to combine the sets, or what is called, what is the operation of sets, that I shall discuss with you in my next video. But before I go, there is one more point that is to be explained in sets only, and that is called the intervals. Intervals means when the set is bounded and when the set is not bounded. If I say a set A is given as X such that X such that 1 is less than or equal to X and less than or equal to 3, and X belongs to set of natural numbers. Okay. I have written it in set builder form. This is an example. In this case, you see, or instead of this, I should write it as R, set of all real numbers. Okay. Now, what does it mean? You see, that means if I say on the number line, this is 0, 1, 2, 3. Okay, that you have understood. If it is say 1 is less than or equal to X, means X can take the value of 1 also. Similarly, it is written as it can be, so it can take the value of 3 also, and it will not go beyond 3. So there is a limit to this. The endpoints are limited. From left hand side, one side it is limited to 1, it will not be less than 1. Other side it will not be greater than 3. Okay, so number of elements will be in between this region only, and that will be limited. Okay, so values will be limited. So this type of interval is called a closed interval. Okay, this type of interval where the endpoints are limited or endpoints are given to you, these intervals are called the closed intervals. There could not be, there is a value or value beyond which it will not be having any member. Okay, but suppose that I just change it a little bit. I just remove this. Okay, now what it is said, 1 is less than X and 3 is greater than X. So X is lying between 1 and 3, but 1 and 3 are not included. Remember, so now if I go on this, again I will make a number line. Okay, there is always a number whatever close to it. There is always a number less than that one that will be between 1 and that number, or whatever number you consider, you will be getting a number less than that number and that will be greater than 1. For example, if I say 1.1, there is another number between 1.1, I can say 1.01. I can say 1.001. I can say 1.000001. So whatever number close to 1 you take, whatever number close to 1 you take, there will always be a number less than that number that will be greater than 1. Okay, which will not be equal to 1, but it will be greater than 1, or which will be lying between that number and 1. Whatever is, suppose that this is what, it may be close, there will be a number in between this. Similarly, when you go on other side, you take whatever number close to 3 you take. You can take 2.9, you can take 2.99, you can take 2.999, you can take 2.99999. Whatever number you take, there will be a number which is greater than this number and less than 3, that is between these two numbers. That means the number of elements is not limited, or you are not having an end point to this. These type of intervals are called open intervals. It was necessary for you. These type of intervals are called the open intervals. There are many more topics, or much important, or I should say this what I have given you in this video, because I am seeing that the time limit of this video is crossing my limits, so I would like to give a break to this video, and the remaining topics of the set theory I shall explain you in my next video. And till then, but I should say one thing, the coming part of this chapter on my next video is going to be much more interesting for you. This was only the basic concept that has to be given, basic concepts of the set theory, or the beginning of the set theory. Now the remaining portion, the remaining topics are much interesting, and you will find, once you understand the concepts, you will find it how easy and how interesting and how playful it is. Okay, so before I go, I once again request all of you, just go through this video carefully. First thing. Second thing, if you have not subscribed my channel, please subscribe and also press the bell icon so that you can get notifications in respect of all my upcoming videos. So before I go, I once again request all of you, please keep studying and keep smiling. So till then, goodbye.